Okay, for today, we are going to review a little bit of yesterday, but also talk about how to solve trig equations. What in the heck is a trig equation, so that you can have some perspective on what are these things we're going to solve. Here's a typical one. Sine of 2 theta equals 1/2, for example. Okay, that is a trig equation. And don't think right away, oh, that's on the sheet, sine of 2 theta. I know that one. I mean, that's cool. I'm glad you know that one. But this could be sine of 5 theta just as well as 2 theta. Okay, so you don't think, oh, I got that one memorized, I'm going to pop it on from the sheet. All right, so that's the kind of question that we have today. And inverse sine is related, but it's not going to answer the question just all by itself. All right, so let's take a second and just do a plain old-fashioned inverse sine like yesterday. Let's see if you've got this down. Inverse sine, which, ooh, wait, you should already know this. There's only 2 quadrants where you can be, right? Inverse cosine, there's only 2 quadrants where it can be, and inverse tangent, only 2 quadrants where it can be. Would you take a moment and draw for me the little map that says, here's where I can do inverse sine, here's where I can do inverse cosine, and here's where I can do inverse tangent. Come on, back with me. All right. Don't remember? No. It's easy to forget. You have to watch the video. Otherwise, you'd be lost. Today you're going to be a little losty. All right. Here's where inverse sine was. Raise your hand if you knew that it was over there. Okay. How about inverse cosine? Top or bottom? Top. Inverse cosine's up there. And last but not least, inverse tangent. Pretty much the same as the other one with the slight difference. Pogo, can you tell me why isn't it exactly the same for inverse tan? Hint, there's asymptotes on tangent. Okay, how about this? Would you agree that this is at the spot pi over 2 and negative pi over 2? When it comes to tangent, what do you know about pi over 2 and negative pi over 2 when it comes to tangent? There's asymptotes there. So therefore, you can't touch there. All right, the green one was sine. Sine can touch. Sine can go right up to these and touch these. But tangent cannot. So if I asked you for the tangent of pi over 2, do you get you can't do it? Because it's got an asymptote there. Inverse tangent of pi over 2, can't do it. It's an asymptote. All right, so those 3 are really, really important. So now, knowing that, remembering that, let's go do one so that you only do it in the right quadrant now. And I'd like you to see the difference here. Inverse sine of root 3 over 2 versus sine of theta equals root 3 over 2. This one is an inverse sine question on the left. This one has only one answer. This one has 2 answers. Would you please find both? And in a moment, I'm going to ask you to check with the kid next to you to see if you got the same answers. Do it with inverse sine, where you're only getting one answer. And then do it with not inverse sine, where you're going to get 2 answers. All right, I'm going to pause for a second while you do that. Okay. You limited to only these 2 quadrants, so these are out. So then on this one, Where is sine going to be positive? Right there. Couldn't use the other quadrant because sine would have been negative. So sine is opposite over hypotenuse. And that must be a 1. And then what's across from that? 60. Except we don't use degrees anymore. We use radians. And therefore it's what? Pi over what?
Pi over 3.
Pi over 3 is the correct answer. That angle right there is pi over 3. All right. And this other one has another answer. It's got the same one over here. It's identical. So it's already got pi over 3 for that one. But it's also got an answer down here. Why do we care about that? Because those are coming back today. But wait, I thought we were doing inverse. We're doing two things this chapter. Inverses and solving trig equations, where you use the inverse as a little step in the process. But bottom line, you got two answers for this. Pi over 3 and then a whole bunch of pi over 3s. What was that? Was it like 6 pi over 3? What was it? I know what you're thinking. This is 5 pi over 3, but you were thinking, oh, you have to say that as a negative angle. Did you see any inverse in this problem? Then it's not a negative angle. Yes?
Wait, but if you put it down in that quadrant, wouldn't it be negative part 3 over 2 though?
Dang, I think you're right. Thank you. Why wasn't anybody saying that? You're all just sitting there.
I was staring at you. I thought that was...
Staring at me. That doesn't work. I can't believe I just did that wrong. And you're right. It's not there. Why didn't you stop me? All right. Where else is sine positive? Over here. Okay. I was going under this assumption because I looked back at this drawing and I thought, oh, that's the other place I can do it. No, it's not. That's the only other place that inverse sine exists. This isn't an inverse sine question. At least it makes that point. I was thinking like it was an inverse sine question, but it's not. All right, so back to this. And why didn't you guys say something? You realize I don't really know what I'm doing, right? Okay. All right, anyway. Square root of 3 and 2, and this must be negative 1. And then this must be a bunch of 2 pi over 3s, and therefore, well, it can't be 3 pi over 3. That'd be 180, so it's got to be 2 pi over 3. Oh, there. How about that? How many of you guys agree with that one? Okay. Okay, good. Now, what was the difference? Well, this one on the right, this one over here, this guy, he can totally have multiple answers. This one, you're only going to have one answer. Now, the ones we're doing today, going to look like this. And I'm going to purposely use 3 theta so you don't think, ooh, I'm going to go grab the thing from the sheet. Sine of 2 theta equals 2 sine cosine. This is different. So I'm going to use sine of 3 theta equals 1/2. All right, to solve this question, I want to make sure you understand what sine really looks like. All right, so the question you just did a second ago was sine of theta equals 1/2, and you found that you got 2 answers. Let me show you why you got 2 answers. Do you get that sine goes forever this way, and if I want to extend it out, it'll go forever that way too? Where is sine equal to 1/2? That was you drawing in this line. Y equals 1/2 and y equals sine theta, and see where they cross. The answers were here and here. Why didn't we mention all the other answers? There was an answer here and here, and there was another answer here and here. You get what I'm saying? We only give the answers between what? 0 to what? To 2 pi. That's why we stopped. We only go from here to there. I actually missed it a little bit. Up to there. That's where 2 pi is, right? Do you get that, and this is important, it's going to be important later, that this could be replicated by adding 2 pi to it? So my first answer, which was pi over 6, do you get that? Okay, just to clarify, I know you didn't do sine of 1/2 before, but I hope you remember that this is 30 degrees. Sine of 30 is 1/2. Does that ring a bell? And then for pi over 6 is the first answer. All right, so back to, so if this is pi over 6 right here, also known as 30 degrees, 6, then I could add 2 pi to it and get more answers. In fact, couldn't I just keep on adding 2 pi and keep on getting more and more and more answers if I wanted to? Yes, I could, and that's important to know because that's what we're going to kind of do in a minute here on this problem. Okay, so to solve the green problem, your first step needs to be what's called a U-Substitution. You need to grow up and learn a big, cool strategy that you're going to use in calculus a lot. And it is called a U-Sub. And the U-Sub is you substituting a U, the letter U, for something complicated in order to make the problem simple. Would you agree that you'd like this problem better if it just had a theta here? It would just be sine of theta equals a half. That you could do. Well, you can't just go around changing problems to make them super easy, but you can do a substitution, and you put in a U, and that's the universal sign for I'm doing a substitution here. And I'm going to let, and yes, you have to write this on your test, let U equal 3 theta. I did a very strange 3. I'm going to try that again. That means now my new problem from here on is sine of U equals a half. You just did one like this a second ago. I did that to warm you up. So, do you see the word inverse or the little symbol for inverse or the word arc anywhere on this problem? Then this is not an inverse trig question. But here's where inverse trig could be used to sort of help. Do you get I could take the inverse sign on both sides and turn it into an inverse trig problem? But I'm artificially adding that later. That's not in the problem to start with. So that's how this is even related to inverse sine. But I'd like you to just solve this the normal way for U, just like we did 2 minutes ago. And yes, there's 2 answers for this one. And then I'll tell you what to do after that. Find the 2 answers for U. U must be like pi over 9 and 3 pi over 9 or whatever. Find me my 2 answers. This isn't complicated yet. It's just like the problem I showed you at the beginning of the hour. Would you check with the kids sitting next to you, please, and see if you got the same answers as they did? There's 2 of them.
That's what I like to hear.
Okay. Where is sine positive? Here and here. Sine is opposite over hypotenuse. 1, 2, square root of 3. And same thing over here, except one of these is negative. And then the angles in question, that angle, which is the one across from the one is a 30, but I got to think in radians, so that's pi over 6. And then a whole bunch of pi over 6s. So I got pi over 6 and 5 pi over 6. Raise your hand if you had that one right. Now, was that theta? No. That was U. So please write U equals pi over 6 and U equals 5 pi over 6. You just solved for U because we made the problem a lot easier by swapping out that 3 theta and getting it out of there. Now, I want you to see what this would look like on a graph. Just a second here. What you just did effectively was take sine, which looks like this, and you said you wanted sine to be a half, which is like this, and you just found these 2 answers. You get what I'm saying? All right. Now, we need to figure out what the rest of the answers are. because the original problem was really sine of 3 theta. When you put a 3 in there, do you get that seems like it's going to stretch it horizontally, but it actually does what? Shrinks it horizontally. So that means the graph, which used to go to here, is now going to go a lot. It's going to get squished. And now there's going to be a whole bunch of answers. Let me show you. I'm going to make sure you really get this. I'm going to try to do this well. That's where 2 pi is, right? And if I put a 3 on the inside, that means it's going to have a new period. Its new period is going to mean that it's going to give us, it's going to complete 3 cycles by the time it's done. 1 cycle, 2 cycles, 3 cycles. Do you get that means? We will now have a whole bunch of answers. 1, 2, 3, 4, 5, 6. There will be 6 answers. That's why there's 6 answers, is because we just squished it down and made it do its thing, its complete cycle, 3 times between 0 and 2 pi. Okay, so I'm trying to explain why there's going to be 6 answers. I could have just done this all with algebra and said, just do this, and it'll work. Okay, but I'm trying to show you why there's 6 answers, not just 2. All right, so back to here. We've got our 2 answers, u equals pi over 6 and u equals 5 pi over 6. Now, u really isn't u. We have to substitute it back in. And now u gets crossed out. What are we going to put in, do you think? Not 3 pi, 3 theta. There you go. So replace your u's with 3 thetas. Okay. Now, your life would be much simpler if I just said solve now. And you just multiply both sides by 1/3 and you'd be done. But you'd only have 2 answers. Do you get what I mean? We could solve this right now. We could multiply by 1/3 and you get pi over 18 and 5 pi over 18 because you're multiplying by 1/3 on both sides. But that's only 2 answers. So now what we got to do is create what's called a term generator. And do you remember before, if you move over 2 pi, you could get another answer that's exactly the same? It's kind of like going around the circle again, and you get the same exact answer you did before. When you go 2 pi more, you can always add 2 pi. But it's not quite that simple because the period isn't 2 pi anymore, is it? You can't just add plus 2 pi. And you can't just keep adding 2 pi forever. So you say, we're going to do 2 pi k. Everybody please add 2 pi k to both of these. Okay, and now that's our term generator. And now, do you get, if we actually added 2 pi, it wouldn't be right because the period isn't 2 pi anymore? So this is the part where algebra will save us. We multiply by 1/3 on all 3 parts of this equation. And look at that. That's my period, 2 pi over 3. It's going to be adding the right amount. Instead of adding 2 pi, we're going to add our period, which is 2 pi over 3. I'm going to multiply everything here by 1/3. And I'm going to clean this up. I now have theta equals, what is pi over 6 times 1/3? Pi over 18 plus 2 pi over 3 times k. You can have the k on top. It would be fine. I like to just think of it as separate. And this bottom one I'll do in red. Theta equals 5 pi over 18 plus 2 pi over 3 times k. Now, how many answers do we want? We want 6 answers. I don't know if you remember that from before, because we squished it down and it's going to complete its cycle 3 times. There's going to be 6 answers. So that's one answer. Why? Because when you put in k equals 0, think about that. If you put in k equals 0, this part cancels out, and the answer is just pi over 18. Then k is our like counter, okay? Especially good if you're a Russian. K for counter. That's going to be 2. Or sorry, that's going to be 1 next. And that's going to be 2 next. All right. So I've put in k equals 0, and I got pi over 18. That's my first answer. I put in k equals 1, and then I actually have to do math. Pi over 18 plus 2 pi over 3. Wouldn't it be nice if this had the same common denominator? I times by 3 on the bottom, or sorry, 6 on the bottom and 6 on the top, because then I'll make it over 18s. That way they have a common denominator. And that makes it 12 pi over 18. 12 pi over 18 plus 1 pi over 18 makes 13 pi over 18. Then I'm going to put in something else. Take a wild guess. I put in 0 and I put in 1. What do you think I might put in next? 2. Now I'm going to put in a 2 there. And this becomes 24 pi over 18 plus 1 pi over 18 makes 25 pi over 18. And you know how you know when you should stop? Once your answers get bigger than 2 pi. Is 25 pi over 18 bigger than 2 pi? No. 36 pi over 18 would be 2 pi. So if it gets bigger than 2 pi, you've gone too far. All right. Now I'm going to go work on the bottom one, because logically, if I want 6 answers, I'm probably going to get 3 from the top one and 3 from the bottom one. So now I'm going to go focus on this one for a while. Would you please do what I did? Stick in k equals 0, and you get the first easy answer. Stick in k equals 1. You'll have to get a common denominator, and you can get the second answer. Stick in k equals 2 and get the third answer. Put it down. You're falling asleep. What's on the board here that I just circled? Right here. You're using this. You're sticking in k equals 0, k equals 1, and k equals 2. Getting me 3 answers. All right, I'm going to pause for a second while you give this a try. If you've got all 6 answers, then you've done it. Okay, so the first one was like a no-brainer. You stuck in k equals 0, and you get 5 pi over 18. There's 2 more answers. Please check those last 2 answers with the kid sitting next to you. Stick in k equals 1. Stick in k equals 2. All right. So I keep asking you to compare with the kid next to you, and only a couple people are comparing. My theory is that you don't know what to do. So I'm going to show you really detailed what you should do. We stuck in k equals 0, and that was easy. It just makes this term cancel here, right? If I stick in k equals 0, that's why I get the 5 pi over 18. Now I'm going to stick in k equals 1 and put a 1 right here. That means I have to add this plus that. And 1 times it doesn't really do anything, so I'm just going to ignore the 1 times. And then I have to get a common denominator, so I'm going to times by 6 and times by 6. And that makes, oh, you could have just remembered this from last time. Our new period is 2 pi over 3, also known as 12 pi over 18. So you just have to keep adding 12 pi over 18 to this. So let's add 12 pi over 18, makes it 17 pi over 18. Raise your hand if you had that one right. Awesome. And then the last one is add another 12 to the 17. Makes it 29 pi over 18. Did I go over 2 pi yet? Nope. There's your 6 answers. I gotta zoom out a little bit to be able to see them all. Remember me saying that this class would get so hard that eventually you'd have 6 answers on a question? You've made it. All right. I think we should do one more like that. Before we try to go confuse you with something else, let's finish this one off and make sure you really got it, okay? Does this only work with sine? Of course not. Cosine will be the same. All right, so let's do this. Cosine of 3 theta. You know what? We'll make your life a little better. We'll just say 2 theta. Because that way, take a guess how many answers I'm going to have now. Twice as many as normal. Normal would be 2. Therefore, 4. Okay. Equals, and we'll make it 1/2 again. It's fairly simple. Hint, in case you forgot, let u equal 2 theta. And then you rewrite it as cosine of u equals 1/2. You get your nice 2 simple easy answers. Then don't forget the plus 2 pi k thing. I'm going to pause while you give this one a try. Start to finish. See if you can get all 4 answers. I hope you drew your true triangles here and here. And I hope you realized this is not an inverse cosine question. If it was an inverse cosine question, we couldn't be down in this quadrant. But this is not an inverse cosine question. So we're fine to be down there. So our 2 answers would be, remember these are u equals answers. U equals, darn it, I just messed up where to put my 1s, 2s, and root 3s. I don't think you guys probably even did that wrong. I did. You probably weren't looking where I was writing them. Okay, so it's u equals 60 degrees, also known as pi over 3. And u equals the other answer, a whole bunch of pi over 3s. Did you get 5 pi over 3? Did I do that right? I hope I did. Raise your hand if you had pi over 3 and 5 pi over 3 to start with anyway. Okay, good. All right, then I have to do my plus 2 pi k thing. And let me give you a snappy saying. If you ever have u in your answer, you should know that you did it wrong. Know why? Because u was a substitution. And if you ever have a u equals, that's a kind of a clue to you that you just did it wrong. So I got to swap that out. That's right. U isn't u. U is 3 theta. And I got to remember that I need, 2 theta. Sorry, 2 theta in this problem. And I got to add that 2 pi k thing. And it's very similar to last time, but last time our answers were in pi over 6s. These are pi over 3s. And last time we had 3 theta and not 2 theta. It's still very similar. All right, I'm going to clean this top one up, write it in red. 2 theta. Actually, I'm going to multiply everything first by 1/2. And now it is just theta. pi over 6 plus the 2 and the 2 cancel. Oh, sweet. It's just pi k. That's really nice. And the other one, 5 pi over 6 plus, again, 1/2, 1/2, 1/2 pi k. And then let k be 0 and 1 and 2? No. If you noticed, if you put in 0, 1, 1, and 2 like last time, you would go over 2 pi. Your answer's going to end up being something bigger than 2 pi. So that'd be bad. If I put in 0, then I get an answer of pi over 6. If I put in 1, I get 7 pi over 6. If I put in 2, it'd be 13 pi over 6, which is too big. It's beyond 2 pi, so I stop there. And this one's 5 pi over 6, and put in 1 for k, it'd be 11 pi over 6. There's your 4 answers. Raise your hand if you were able to complete that. Sweet. Now that is a serious trig problem. That is solving trig equations. All right. I want to end with, because on our homework we have some more of those nested ones. I want to end with one of those nested inverse trig questions. So let's do the tangent of the inverse cosine of 1/2. Hint, start on the inside. Second hint. Alarm's going off, so I have 12 minutes left. Third hint. Cosine, inverse cosine, which this is an inverse trig question, has restrictions, so you're only going to get one answer. Unlike the other one where you just got 4 answers. And the one before that where we got 6 answers. You better only get one answer for this. Last but not least, do the tangent of the triangle that you draw. Draw a triangle for it in the right spot. It doesn't appear that you're drawing a triangle. Okay. I'm going to start because we're limited on time, and you guys are probably ahead of me anyways. Where can cosine be positive? Oh, here it can't be here and it can't be here. All students take calc, so it's got to be in the A or the C, also known as the first or the fourth quadrant. Then I'm going to go here, adjacent, over hypotenuse. Ooh, we just did this one. So it's pi over 6. No, it's pi over 3, I think. Anybody agree it's pi over 3? Awesome. Then I would get it wrong if I said the answer is pi over 3. Because what am I supposed to do at the end? Tangent. Tangent is TOA, opposite over adjacent. Root 3 over 1. Because I'm supposed to do tangent of pi over 3, which is root 3 over 1. Final answer, root 3. Does that make sense to you? Believe it or not, we really only have, like, at this point, if I gave you the test today, you could do 3/4 of the test. Okay, so most of the test is this stuff. There's a little bit of cleanup left. I got to finish off a couple of the little things, but then you've learned a lot. All right, now we're going to go find the homework on this. I'm going to pause for a second when we do that. Okay, the assignment one looks kind of weird. It doesn't. Okay, so we're going to do number 2 and number 7. And what's different about number 7? It's cotangent. What the heck? Well, do you remember how you can rewrite cotangent and not do cotangent and instead do its sister function? You just have to remember to flip the answer. So your first step is to say, I'm not doing cotangent. I'm going to do tangent of 2x equals, and then flip that fraction over. 3 over root 3. I also want to encourage you to remember that that is the same as another famous one that you're more used to. So when we flip it, it'll be negative 3 over root 3. Does anybody remember what that one's the same as? It's been rationalized. Well, I'm going to let you figure it out. All right, and I'm going to go to this one on the next page. Now, I know this looks like totally different. It's not. At the end, you're just going to substitute that for a u, solve the question. Anybody remember that one? Root 2 over 2, that's the same as 1 over square root of 2. If I were you, I'd change that out for a 1 over square root of 2 because it is easier. All right. And at the end, you swap out your u for a x over 3. So basically, you multiply everything by 3 instead of dividing everything by 3. All right. I think we don't need to do this many of them. We're going to cross off all of the rest of those. We're just going to do number 9. You realize how much time I just saved you. And I hope that you actually do the ones I'm assigning. I'm going to stop right there. Oh, wait. Otherwise, you're going to be lost on the tests. All right. And I think that's good enough. Review. I want going to be nested ones. Do a review at the end. Oh, there isn't one. I thought. I'm going to make you one nested one I want you to do. This is rare. I'm adding a homework question that I think should exist if it doesn't. Okay? I want you to do tangent of the inverse sine of negative root 3 over 2. I know these are important, and I don't think you had enough practice on it to just do it for one day yesterday and think you're good at it. So I'm going to add that to everybody's homework tonight, just that one question. I hope it's easy enough that you can live without having a key on it, because you won't have a key on it. You can always check with a buddy. Okay, that has cut the homework down dramatically. You need to do your part and actually do the ones I assigned. You can always do more if you want to. You had a hand up for a while. How can I help?
Wait, so are you gonna have test vectors?
Good question. I'll do that for you immediately. All right, that's all I have for the video for you for today.